Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuhu. How are you, everyone? I hope everyone is doing great by the mercy of Almighty Allah. Welcome to my channel, Easy Learning with Sadman Sir. And in today's video, we are going to discuss about pressure inside a liquid. So let's begin. So let us say we have a jar or pot which is filled with a liquid. For example, for now, let us consider this one as water, or it can be any fluid or any liquid. Okay. So definitely it will have a bottom surface, and let us say that the area of the bottom surface is A. Now, to calculate the pressure, we will be in need of the depth of the liquid, okay, the depth of the bottom surface from the free surface. So as you can see here, this is considered as the free surface of the liquid, right, which is in contact with the environment. So from here, the depth of the bottom surface is h. Now there might be a misconception in many people that this h goes to represent the height of the water bar, but it is not height. We will mention it as depth. Now for instance, these two might seem of the same concept, of the same meaning, height and depth, right? But we will get to see when we go to solve some mathematical problem, we will get to know the difference between the depth and height in this case. Okay, so for now, let us just keep it in mind that this h does not represent height from the bottom surface, rather it represents depth from the free surface. Okay, then we know that as it is filled with liquid, on the bottom surface it will be exerting an amount of force. Now what is that force equal to? If I want to calculate the pressure inside the liquid, I have this equation, pressure is equal to force by area. Again, that brings me to this question, that what force is being applied here, right? Whenever some force will be applied, we will divide it by the area and then we will get the pressure. So the first question, what is the force that is being exerted on the bottom surface? Now let us think about it in this way. If we are standing on the ground, let us say this is the ground, okay, and someone is standing on the ground, so definitely that person will be exerting a certain amount of force on the ground. The question is, how much force will that be? That force will be equal to the weight of that person's body, right? If he has a higher weight, then he will be exerting a larger amount of force, and if he is thin and has less weight, then what will happen? The force exerted by him on the ground will be less. So like that, can we consider that this bottom surface is the ground, and on the ground this water is standing? So definitely this will exert a force on the bottom surface that is equal to the weight of this liquid. Okay, so here the force can be considered can be written equal to the weight of the liquid, correct? Now what is the equation to calculate the weight? We already know that W is equal to mass into acceleration due to gravity, that is mg, right? So definitely we can say that the force that is being exerted is equal to the weight of the liquid, and that is equal to mass of the liquid into acceleration due to gravity. Now this F can be replaced by W, and further W can be replaced by mg, and we have done that already. Now to find out an expression for m, we have to go back to the equation of density. If you remember from the concept of density, we got to know that rho is equal to m by v. Rho represents density, m represents mass, and v represents volume. So from here, if I want to find out an expression for m, I must cross multiply this rho and v, correct? So that will give me m equal to rho v. Now this v, volume, can be written is equal to area into height, correct? Why? Because generally we know, for example, if it is confusing to some people, then I will explain it in this way. Volume equal to, we know that length into breadth into height, where area is length into breadth. So this length into breadth can be replaced by area A. So volume can be written equal to area into height. That is actually for a rectangular box, even though we have a cylinder here, but still we get the concept, right? So V can be replaced by area into height. So mass is equal to, we are getting rho AH. Now this mass we can easily replace by rho AH. So the expression will become P will be as it is, mass will be replaced by rho AH, and into G, G will be as it is, right? So you can see that there is A in the numerator and there is A in the denominator. So they will cancel each other. So it will finally give us the expression by which we can calculate the pressure inside the liquid, that is H rho Z. Now again, I will mention that this H represents the depth from the free surface, and rho represents the density of the liquid or fluid, and G represents the acceleration due to gravity. Now, if we continue our discussion, let us say that we are using the same liquid, okay? We are using the same liquid. Now, the density will be constant that time, because if I'm not changing this liquid, the density will not be changing. Whenever I will change the liquid, that time only the density will change, correct? So for the same liquid, what happens? The density remains constant. For example, if I want to find out the pressure at this point, or at this point, or at this point, if I change the point at which I'm trying to find out the pressure, then the depth from the free surface will be varying, correct? But the density of the liquid, it will not change, because for the same liquid I'm trying to find it out. So that is why for same liquid density remains constant. Now here G is already a constant, acceleration due to gravity, and we put the value of G as 9.8 meter per second square always, and rho, it will also remain constant when the liquid is not changed. So in this case, what will happen? The pressure will directly depend on the depth of the point, right? That is what we will see. The pressure will become proportional to H. If H is doubled, that means depth is doubled, then what will happen? Pressure will also become double. Okay? So we can say that the deeper we go from the free surface, the higher the pressure rises. Okay? Now let us take a look at a figure which will clearly show us actually what we discussed. Now, this is a scenario that we might have seen in our regular life. Let us say we have a water bar here and we made a couple of holes, okay? Now, we can see that through this hole, the water is coming out, okay? Now, what is the depth of this point from the free surface? The depth is less, right? Compared to other holes, the depth is less. So, as a result, the water is coming out at a very low pressure, correct? Less depth, less pressure. Now if I increase the depth, that means if I go deeper, okay, let us consider this hole now. What we can see? We can see the water is coming out at a little bit more pressure, and that is why it is traveling a little bit more distance than the first stream, correct? So it goes to show that water is coming out at a higher pressure, and the water will come out at the highest pressure. Where? Out of the three holes that we have made, this one is the deepest, so the water will come out with the highest pressure out of the three, right? And you can see that the water is falling at a very far distance, and that goes to show that the pressure is very high here. So what we understood from here, the deeper we went, the pressure rose, right? And that is what we actually got to see in the previous slide. If the value of H increases, the pressure will also increase. Not only the relation is only increasing, the thing is, if you double the depth, the pressure will become double. If you triple the depth, the pressure will also become triple. That means they both will change proportionately in the same proportion. Okay, then let us see a practical problem. You can see that there is again same water jar is here, and it is filled with liquid, and we need to find out and compare the pressure at the points given, that is A, B, C and D. Okay, so A is at a certain depth, B is at a certain depth, so all the points are at different depths, and we need to find the pressure at this point. So how can we do that? So I will show you a sample calculation, like for one point, and for the other point I want you to find out, okay, so that you may judge or check with how much you understood. So the first point is A here, right? So for A, the pressure will let us represent it by PA. So it is equal to H rho G. So when we will put the value of h, see, here we will get a clear idea about the depth. Okay, we are not considering the height from the bottom surface. No, we didn't take this measurement, rather we took the depth from the free surface. Okay, so now it is clear that h represents the depth, not the height. Okay, depth from the free surface, not the height from the bottom surface. So that is why we will put the value of h as 3 meter. Okay, and the density of water, it is given here, even if it is not given in the question. Okay, you can put it as 1000 kilogram per meter cube. That is the density of pure water at 4 degrees Celsius temperature, and G is 9.8, as always we know. So if you calculate, we will get to 29,400 Pascal. This is the pressure at A. So in the similar manner, by just changing the value of H, okay, we can find out the pressure at B, C and D. Okay, so B is at 6 meter depth from the free surface. So the value of H, we will put 6, and then the rest of the value will be same, and then we will get the pressure at point B. Okay, so I pause the video here and do the calculation, try to find out the pressure at all other points. Okay, and then play the video to check whether you got the correct answer or not. So pressure at B will be 58,800 Pascal. Pressure at point C will be 9,800 Pascal, and pressure at point D will be 29,400 Pascal, which is the same as point A. Now, why the pressure at point A and D are same? Can you say? Yes, correct. Both of them are at same depth, as you can see. A is also at 3 meter, D is also at 3 meter depth. So both of them will have the same pressure. It doesn't matter where is the location. If they're at the same depth, then what will happen? Both of them will have the same pressure. Now, we already did the finding part, right? Now we need to compare it. So let us compare. So at first, at point A, we saw that the point is at depth of 3 meter from the free surface and the pressure is 29,400, and similarly the information I will list up for B, C and D. Now the point that I want you to notice is when the depth was doubled from 3 meter we went to 6 meter, you can see that the pressure also became double. If you multiply 2,900 by 2, you will get 58,800, correct? So they both change in the same proportion. And then when the depth became one third, okay, that time the pressure also became one third. So if you multiply 2,900 by 1 by 3, then what will happen? You will get 9,800. And at the same depth, 3 meter, the pressure also remains same. So this goes to show again that pressure is directly proportional to the depth of the point at which we are trying to find out the pressure, given that the density remains same. We will not change the liquid, we will not change the density. At that time, pressure will be directly proportional to the depth. Okay. So the last point that I want to mention before ending today's session is sometimes in the exam you will see that the depth might be given in centimeter. You need to convert it into meter in order to get the pressure in Pascal. They might ask you to find out the pressure in unit of Pascal. So that time, if it is given in centimeter, let us say it might be given in 300 centimeter. So that time you have to convert it into meter by dividing it by 100. Okay, let us say 300 centimeter was given, then you need to convert it into meter. How? By dividing it by 100, then you will get it in meter, and then you have to put the value of h here and do the rest of the calculation. Okay, so that's all for today. If you have any doubt regarding this, then you may write in the comment section, or let me know how useful was the explanation for you. Was it easily understandable? I'm always fond of getting feedback, like whether it is positive or negative. I will welcome it with an open heart. So if the video helped you, then give a thumbs up and subscribe the channel for the future videos. So And again, if there is any question regarding this topic, then please let me know in the comment section. I will get back to you, inshallah. Happy studying. Stay well. Assalamu alaikum wa rahmatullahi wa barakatuh.